Hello friends, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss noise. So noise in analog communication system and types of noise. And again, white noise. Now coming to the topic. So what is the noise? Noise is an unwanted signal which interferes the original message signal and corrupts the parameters of the message signal. So already you know the parameters. One is maybe amplitude, or phase, okay, frequency. So noise generally affects amplitude and phase. Okay. So in general, noise may be predictable or unpredictable in nature. The predictable noise can be estimated and eliminated by proper design. But unpredictable noise varies randomly with time. We have no control over this noise. That means we are going to suppress but not eliminate this unpredictable noise. So we can classify the noise in different varieties, but generally having two classifications, that is external noise and internal noise. Again, external noise can be classified into atmospheric noise, extraterrestrial noise, man-made noise, whereas in internal noise, that means in the system. This external noise means this is coming outside from the system, whereas in internal noise, it is within the system. Thermal noise, short noise, transit noise, transitor noise, and a flicker noise. So these are the different noises what are coming in our analog communication system. Okay. So now we are going to discuss one by one. So the first one is external noise. The various forms of noise created outside the receiver come under the heading of the external noise. So in that external noise, the first one is atmospheric noise. Atmospheric noise, which is called static, is produced by lightning discharges in thunderstorms and other natural electrical disturbances which occur in the atmosphere. Why? Because these all are received by the antenna. So that's why this atmospheric noise, which is going to add it to our signal. And extraterrestrial noise. So there are several types of extraterrestrial noise or space noise depending upon the sources. So extraterrestrial noise may be divided into the following two subgroups. One is solar noise and another is the cosmic noise. So the name solar noise, that is really coming from sun, and another is the cosmic, so that is maybe stars like that. So first one is the solar noise. Solar noise is a electrical noise emanating from the sun. Why? The sun is a variable star and undergoes cycles at the peak of which electrical disturbances erupt, such as corona flares and sunspots. And the solar cycle, repeats every 11 years. That means the radiation from the sun is changes. Not constant radiation is coming from the sun. Every 11 years, the solar cycle repeats. So this radiation and electrical disturbances is varying. And coming to the cosmic noise. So this cosmic noise is coming from the distant stars. Why in our universe we have different number of stars are there. So these distant stars having very high temperatures, and therefore they radiate noise in the same manner as the sun. So space noise is observable at frequencies in the range from about 20 megahertz to 1.43 gigahertz. And coming to the industrial noise. The industrial noise or man-made noise is the type of noise which is produced by such sources such as automobiles and aircraft ignition, electric motors, switching gear, leakage from high voltage lines, and several other heavy electrical equipments. That means this is due to the man. Why? Because the automobile doesn't start its work, and man is going to start and make some noise. Like that, everything which coming from that man, that is man-made noise. And another is internal noise. So internal noise is that type of noise which is generated internally or within the communication system or receiver. So internal noise may be classified as thermal noise, short noise, flicker noise, and transit time noise. So these are the four varieties. Okay. Now the first one is thermal noise and internal noise. The noise generated in a resistance or resistive component of any impedance is random and is referred to variously as thermal, white, or Johnson noise. Why? Because the electronic circuits or electric circuits which is designed with resistors. So that noise is coming from that resistance. Okay. According to the kinetic theory of thermodynamics, the temperature of the particle is a way of expressing its internal kinetic energy. So this thermal noise is also considerable. So therefore the noise power produced in a resistor is proportional to its absolute temperature. Also the noise power is proportional to the bandwidth for which the noise is measured. So therefore Pn proportional to Tb, and finally we can say the noise power which is equal to Ktb, where K is Boltzmann's constant, T is temperature, and B is the bandwidth. And coming to the short noise is caused by random variations in the arrival of electrons at the output electrode of an amplifying device, and thus appears as a randomly varying noise current superimposed on the output. So this short noise is majorly coming from the amplifiers. And another is white noise. So noise is an idealized form is known as white noise. That means the name why white noise is coming. So we know that white light consists of all color frequencies in the same manner. White noise contains all frequencies in equal amount. Actually, the power density spectrum of white noise is independent of frequency. So if the probability of occurrence of a white noise is specified by Gaussian distribution function, it is called as white Gaussian noise. So the power spectral density of white noise is expressed as omega of omega, which is equal to n0 by 2. So n0 by 2 is the power spectral density of white noise. So we can say the power spectral density images, that is n naught by 2. So we can see that is which is a palette Verisi line. That means all the frequencies are equal. So it is called as white noise. And it's also autocorrelation is also given. Okay. So the autocorrelation function of the power spectral density of white noise may be obtained by simply taking the inverse Fourier transform on both sides of the expression. So we get our omega of tau, which is equal to n naught by 2 into delta of tau. So delta of tau is coming from that impulse function. Okay, so these are the different noises which is come in this analog communication system. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.